Good evening, ladies and gentlemen. Thank you for giving me a screen and organizing also for giving me opportunity to speak. I will discuss today in mm, about work of Professor Gerasimos Liberatus' latest work about dark fermentation of from fruit juices, and then the rest, which will be uh, not converted by dark fermentation, then the rest would be probably producing some plastics from cyanobacteria, because the cyanobacteria also some found by Gerasimos that produce polyalkoxynate, which can be starters, primary organic material for polylactic acid or other polymers. Let's say how it started. The fruit juice were decided to choose 20 to 40 gram per liters, and then as production of bacteria, he uses this wastewater of these juices. The mix was of 9 fruit juices: apple, lemon, pineapple, all 9 juices produced by some factory. The pH of these juices was 3.6, so similar to sour cabbage, and with high content of sugars. Sugar contents of fructose, glucose was to 120 gram per liter. So this solution as 20 gram per liter was filled in the upflow column reactor with porous beds. These porous beds were functioning as the place of bacteria of layer, where this juice would be has greater area of reaction, bioreaction. Therefore, greater part of juice would be digested. The flow rate was 24 hours. So 24 hours was staying to sugar, then leave this reactor, and the rest was by cyanobacteria from Zoliega, and found that they can produce. So these bacteria were supplemented by ammonia and phosphate buffer for better solution, because Professor Dr. Entyko was helping. This both solution helps to improve the fermentation, the conversion of from fermented by dark fermentation. Then also this plastic was, beside this zoiga, was also converted by for the lipids rest from this were so Libya, which producing the cyanobacteria were producing the lipids, and therefore the effluent was better digested and converted and volatile acid were produced also by digesting these bacteria rests, which were earlier in the two-second stage, because this solution was for three-stage dark fermentation. First, the treatment of one kind of bacteria to digest and form, and these lipids which react with other bacteria, giving the very converted and many products process, because we have lipids, polymer status, and hydrogen production. This is the case because the conversion to dark fermentation on the hydrogen gives too little process. And also they observe the production of hydrogen sulfide. Though. And then we show us that they check also crystallinity of these polymers of polyhydroxylate from this Solosky cyanobacteria, and read that result was 30% crystallinity, so very high. So this could be used in polylactate of high temperature resistance. So this is good information that we can replace this, which are both by hydrogen, and replace conventional method of polymers by this way. This is important because this shows that besides pyrolysis, there are also some quite economically, because pyrolysis, as you remember, requires bad heat, but this is illegal, maybe not very high efficiency like pyrolysis, but still less energy. And this is the way that if we modify, probably we have higher conversion, and is this the solution that will help us to produce both raw materials for plastic and some supplementation energy by conventional method, and extraordinary we remove some waste. And this is the solution that it is also showing that dark fermentation is very useful for in case of industrial processes, which can use this. They need some hydrogen, and this hydrogen will be already by upgrading the products. The conclusion is that we have the degree was dark fermentation useful as initial step for production of many raw materials for other bacteria, because dark fermentation can feed on many solutions and many waste, while cyanobacteria and other for less. But the cyanobacteria can use feed firstly converted by dark fermentation. So this shows that dark fermentation would be starting point and or anaerobic for other biological utilization, and this is shown that our future prospects of our renewable, sustainable live in good condition. So thank you very much. This is all for today.